students encourage you
Is everybody ready? We're ready. Ready. All right. Here we go.
Arming, props are spinning, throttling up.
Altitude.
Oh my god.
20. Props are spinning, we're up. We're about 10 meters. 40. 50. Transitioning to cruise in 3, 2, 1.
One year ago, I stood here hoping to show you a similar video. The team and I naively believing that we could take off and watch our aircraft soar across the sky, all in one spectacular maiden flight. Alas, it was only several months later and after many failed attempts that we could achieve even a stable hover. We've come so far since then, faced and overcome many challenges in what's been an incredible year of learning, perseverance, and growth. Good evening, everyone, and welcome to the Monash Uncrewed Aerial Systems 2024 Showcase. Before I begin, I would like to take a moment to acknowledge the Bunurong people of the Kulin Nations, traditional custodians of the land in which we gather here today. I would also like to acknowledge the Wadawurrung and Eastern Maar peoples, traditional owners of the land in which we test, where much of the footage shown here today was captured. We pay our respects to their elders past, present and emerging. This always was and always will be Aboriginal land. When 2023 began, Monash UAS was a very different team to the one you see before you today. Over 2/3 of the team's experienced members had recently graduated. We were down to a skeleton crew of just 30 active members, and our first aircraft since before the pandemic had only just begun to take shape. Fast forward to today, and the team has regrown to over 100 members with an array of new roles, allowing us to train members in new disciplines and strengthen our understanding of old ones, all whilst developing and flight testing not one, but 2 full-scale aircraft. 2023 was about getting back on our feet and back in the sky, and I'm pleased to say that we have done just that. We set out the year with 2 goals in mind: to learn and to grow. With such a young new team and having just built our first aircraft in several years, there was much to experience for the first time. Quite possibly the most significant of these experiences was flight testing. 2023 was a year that Monash UAS returned to the skies, and we did so on 26 separate occasions with over 100 successful flights, each time walking away having learnt a little more. We couldn't have achieved this, however, without three very important people, and while there will be many thank yous tonight, I would like to take a moment to acknowledge a few individuals without whom we wouldn't have gotten to where we are today. To Mr. Lachlan McDougall and Mr. Philip Eunice for your kindness and generosity in allowing us to test and stay at your beautiful properties. Thank you for being so accommodating and hospitable. The team and I cannot express enough how grateful we are for your continual support. And to Mr. Paul Riseborough for advising us in our mission to tune the Albatross. Suffice to say, I don't think the team would have landed safely back on the ground without your help. You have taught us so much, and this knowledge will continue to help not only UAS before you today, but the team well into the future. On behalf of the team, I would like to invite each of you to the stage for a small token of appreciation. Paul and Lachlan, if you could please accompany me to the stage. I know Philip is watching online, and we'll be sure to drop your gift down next when we venture down. Can I please get another round of applause for Mr. Lachlan McDougall, Mr. Philip Eunice, and Mr. Paul Riseborough. At Monash UAS, our mission is to demonstrate the humanitarian potential for UAVs in civilian and emergency response applications, whilst inspiring and educating the next generation of engineers. And we do so through the three pillars of our mission statement: demonstrate, educate, and inspire. By highlighting the gap between what drones can do and what they could do, we hope to broaden the adoption for UAVs in emergency applications and prove to the world that drones have use beyond just defence and cinematography. In doing this, we aim to push the boundaries of existing technology and equip the next generation of engineers with the knowledge and skills to create positive changes in their communities and beyond. Finally, through outreach events and workshops, we strive to encourage young minds and disadvantaged groups to pursue careers in STEM, sparking their curiosity, igniting their passion, and inspiring a future generation of thinkers and innovators. The delivery of this mission would not be possible without the important work of our Grade A operations section. These talented people work tirelessly behind the scenes to keep the team running, secure us the best products and services, organise events like this, share our hard work with the world, and inspire the engineers of tomorrow. Could you please join me in welcoming our 2024 Ops Lead, Iris Lai, accompanied by Events and Programs Managers Adwick and Daimi, Sponsorships Manager Alicia Carlana, and Marketing Manager Kai Stabar.
I stand before you today with a heart full of pride and excitement as I reflect on the remarkable journey we've embarked on over the past year. As the operations lead, it's been both an honour and a privilege to witness the incredible achievements of our team unfold before my eyes. In the past 12 months, our operations section has been nothing short of extraordinary. We've undertaken a series of initiatives aimed at fortifying our team, enhancing our capabilities, and amplifying our impact in the world of uncrewed aerial systems. Now let's take a moment to celebrate some of the incredible milestones we've achieved together by welcoming Daimi.
One of the core values and goals of UAS as a whole is to inspire. In particular, to inspire the next generation of engineers. As such, Adwick and I, the current Events and Programs Managers, aspire to restructure and rebuild our outreach capacity to reach as many young engineers and students as possible. It may seem from the outside that UAS is strictly technical focused, but it is our goal not only to expand, but also reinforce the need for a presence within our community. From the moment we joined mid-last year until now, we have engaged in creating new learning opportunities, such as new workshops to run, taking on new roles with schools and the university, as well as reiterating the importance of volunteering within our team.
And moving forward, our events and programs team aims to expand our initiatives in order to reach more young minds and facilitate tangible change in our community. MUAS brings together a unique combination of disciplines from a wide variety of degrees and backgrounds, and all these students are really keen on educating and inspiring the next generation of engineers and young students. We seek to continue to build our current close relationships with various schools that we already have around the region, as well as expanding our outreach programs to hopefully reach even more schools around Victoria. Our events and programs team is a dynamic and really busy landscape, and it's an incredibly rewarding role to have. If you or someone you know is keen to join, we would love to welcome more passionate students into our team. Thanks very much, and I'd now like to invite Alicia from our sponsorships team.
Great. Thank you, Adwick. So I'm Alicia, and as Jordan explained before, the team has reached new heights, expanding our horizons in what we've been able to build as the team has revamped its skills and regained its numbers. A large part of this is thanks to our sponsors, who have been an integral part of our journey. The advice, access to materials, and licenses have enabled us to quickly improve our team's skills as we onboarded new members and tested our new designs. The support we've received from the industry has been invaluable, and we're excited to expand our influence within this space and to show the use of the drone for the humanitarian purpose of search and rescue. So, as we go into 2024, we're excited to have more active relationships with those who've supported our growth through more individualized workshops, but more importantly, workshop tours, but more significantly, an implementation of milestones throughout the year. On these milestone days, we'll be inviting you, our sponsors, to see our progress and let you discuss and give advice to members in person, supporting the team to continue to grow and advance while we also show you our efforts that were made possible because of your direct assistance. Within the sponsorships team, we're working this year to provide more consistent updates and demonstrations of our drone's progress and to emphasize the impact our supporters have made to the team as crucial connections. Thank you. And I'll pass it on to Kai.
Hello everyone, my name's Kai and I'm the 2024 Marketing Lead, and I'm up here to talk about the social media gain that we have gotten this year. Firstly, let's talk numbers. Our social media presence has seen an incredible surge this year, with an Instagram reach of 6,000 and Facebook at 10,000, a remarkable 300% gain. This signifies not only our expanding awareness of the team, but also the hard work and creativity delivered by our marketing team. Now, those numbers were only possible due to our two very successful recruitment drives in 2023. Our mid-year recruitment drive saw a fresh wave of talent and creativity, injecting new energy and perspectives into our media, while our end of 2023 recruitment drive was our most successful yet, further expanding our operations focus. As we look ahead in the future, our marketing section remains dedicated to providing new and engaging media to promote the amazing work our team has done. Thank you. Passing back over to Jordan.
Thank you, Operations, and it's a very exciting year ahead indeed. Whilst our talented marketing team has been hard at work creating the videos that you'll see here tonight, much of the footage featured was filmed by our long-term supporters, XM2, who we were privileged to have joined us to capture our first search and rescue mission trial, the 2023 demonstration. Based right around the corner, XM2 are experts in aerial cinematography with an impressive portfolio of Hollywood titles. And if you don't believe me, allow me to let their work speak for itself. I'd like to give a huge shout out to Aaron, Aidan and Rob for taking the time to come out and film us in action. And if you like that video, be sure to stay tuned for the one that they made for us at the end. At our last showcase, the team unveiled our pride and joy, the Albatross, for the first time, resurrected from the dead after our second attempt at a VTOL takeoff. And this wasn't the only time this aircraft was reborn. V2 proved to be quite the resilient test platform, something that was essential in our quest to tune our control loops and achieve VTOL stability. The team affectionately nicknamed this aircraft Phoenix, symbolic not only of its knack to bounce back, but of the team's revival too. Whilst Phoenix was out in the field for the first 6 months of the year teaching us valuable things about flight testing, the team was diligently designing the next version of Albatross, taking all of the learnings from Phoenix to develop our 2023 mission aircraft, the Albatross V3 Horizon. Structural design to its custom in-house power distribution board Horizon represents a mature refinement of version 2. Designed with search and rescue in mind, Horizon boasts a 3-metre wingspan, vertical takeoff and landing and autonomous flight capabilities, machine-assisted patient detection and aerial aid delivery, making it a purpose-built search and rescue tool designed to both reduce response times and the risk to rescue crews who put their lives on the line to give others a fighting chance. Whether directly related or not, the team undertook many projects this year. And without further ado, allow me to introduce our technical sections, starting with the one that takes us to the sky, Flight Ops. Please join me in welcoming 2023 Flight Ops lead Thomas Abbott and 2024 Flight Ops lead George Dimitropoulos.
Hey everyone, my name's George. I'm one of the Flight Ops leads alongside Jed. Tonight, joining me is Tom, the previous Flight Ops lead before Jed and I. Our section is responsible for the coordination of all things involved in flight testing and the flight of our aircraft. We're tasked with developing the team's capability and maintaining our ground station and our own fleet of drones. Working closely with our pilots, we coordinate and we plan the team's flight days.
On these days, we're in charge of the setup and operation of our ground station system. This allows for two-way communication between us and the drone. We use this to monitor the health of the aircraft via multiple telemetry streams, as well as dynamically adjusting the flight path of the aircraft or triggering certain events such as payload deployment. We're also in charge of analysing all of our logs so that if any issues arise in the field, we can quickly identify and fix them. It also allows us to continually hone our control loop, allowing for safer and more efficient flight.
This year, we also began working with our Avionics stack team, learning from them how to perform the work that they do on the wiring and the integration of all the various systems on board the Albatross. We're a small section at the moment. Members graduating previously left Tom as the only active member and the Flight Ops lead by default.
However, since then, we've been fortunate enough to slowly grow back our numbers, and we're now incredibly excited for the enormous potential we have as a section. With that being said, we'd like you to take a look at the projects that have been keeping us busy this past year.
These motors are overweight and have an inefficient and unoptimized design. Another drawback is the excessive use of aluminum, which require
Flight Ops' greatest achievement this year has been the development of our flight analysis and PID tuning process. At the beginning of the year, we started flight testing Albatross V2 but this quickly became apparent that the preset control loop would not be sufficient for an aircraft of our size or design. This led to the team's foray into PID tuning and control theory. Thankfully, early in the process, we were lucky to meet Paul Riseborough, a control and guidance system engineer and one of the primary developers of the ArduPilot software. With his help, we were able to take the Albatross from an untuned aircraft to one that could fly smoothly. The team has made amazing progress since those initial meetings. First, we learned to identify and resolve a number of issues such as detuned motors, aircraft resonant frequencies, and electrical noise. From there, we tuned the gains on the PID loop, as well as implemented both static and dynamic notch filters to remove any noise that could cause the aircraft to become unstable. From there, we continued to further refine our tune, implementing experimental ArduPilot builds to resolve previously permanent issues, as well as writing our own code to make the aircraft easier and safer to handle in extreme weather conditions. Not only has this allowed us to build a safer and smoother to fly aircraft, but it has taught us a number of valuable lessons in aircraft design, from EMI reduction and vibration dampening to more robust data protocols and feedback sensors. These learned lessons have been implemented in the hardware and software developed for V3, as well as those being developed for V4, allowing us to continue to make safe to fly and smooth aircraft.
One of the main roles of our flight operations section is to build and maintain a small fleet of non-Albatross drones. We do this so that we can train pilots in both VTOL and cruise, and also test systems in flight before they're ready to be installed on an Albatross or when an Albatross is unavailable. Today we're going to be talking to you about two of our main drones, the X8 and the Hex, and the projects that they've been involved with this year. This is our drone, the Hex. It was grounded at the start of the year, so we decided to improve its structural features and rearrange the avionics. We only had 4 motors to replace the existing 6, and we couldn't feasibly change the motor spacing for it to be a quadcopter. For this reason, we were skeptical about its stability, but upon testing, it proved to be a reliable test platform. Through further testing, we discovered a mild instability in certain flight modes, but we plan on using this in future to train new recruits on PID tuning and flight analysis.
Please welcome to the stage 2023 Aerostructures Lead, Rohan Amarasinghe, and 2024 Aerostructures Leads, Tom Buno and Nikhil Pokharel.
Thanks, Lily. Last time we were together, we presented to you Albatross V2, our first flying aircraft post-COVID. And while it brought great achievements and firsts to the team, it also taught us valuable lessons in all departments, from the initial construction to the final flight testings that saw it be crashed and repaired again and again. We particularly had issues with the adhesive holding the airframe together being too brittle, leading to time-consuming repairs, as well as the main battery being an effort to replace out in the field. What Albatross V2 essentially showed us was that while we had a flying aircraft, the key to consecutive successful flights was found in not just the good aircraft design, but also in the seemingly small quality of life items that made it just that much easier to get the aircraft out in the field ready to fly. This was the goal that we had in mind when we started the design cycle for Albatross V3. And to talk about that a bit more, I'd like to invite Tom up to the stage.
Thanks, Rohan. V3 was conceptualized with the dual goals of overcoming the challenges we encountered with V2 and fulfilling the ambitious requirements of a mission-capable aircraft. As we envisioned V3 to be mission-capable, it was imperative to design with specific mission requirements in mind, particularly concerning the payload and the gimbal. This necessitated the design to be much lighter and also optimized for much better internal space efficiency. Furthermore, a significant focus was placed on enhancing the structural integrity of the critical components. The critical components being the crux and the spars. These two components form the structural centerpiece of the aircraft, which mount the wings, fuselage, and tail together. The crux underwent a redesign aimed at not only bolstering its strength, but also optimizing its weight and volume. These enhancements were pivotal in achieving a higher level of durability and reliability, crucial for the requirements of our mission. The development of V3 was a journey of learning and adaptation. We took the lessons from V2, combined them with our ambition for V3, and designed an aircraft capable of completing the requirements we set out for ourselves at the end of 2022. Next, I'd like to introduce Nick, my fellow 2024 Aerostructures lead, who will provide a brief overview of the manufacturing and testing process for V3.
Thanks, Tom. Having come out of our V3 design phase, Aerostructures now had to manufacture another airframe. For the second half of 23, we knuckled down to manufacture an airframe that met our demonstration requirements. And for most of the remaining year, this is more or less what we did. We built the airframe, we flew it, we landed, or crashed, we repaired, and we flew again. Along the way, identifying the issues that caused our failures and acting to address them. For the first time in years, we were regularly testing an in-house airframe, and naturally, that came with its own challenges. As with any flying body, weight quickly became an issue. We found ourselves replacing many existing parts with resin, composite, and aluminium components. Usability and ease of life also motivated new projects such as that Rookery. You can ask any member of our team, and they'll agree that the Rookery was an incredibly successful project. It allows the team to access the airframe in a variety of configurations, and also facilitates a reliable and secure way to transport the Albatross to and from flight days. I think often when we talk about the engineering process, we overlook the logistical challenges. While it's true that Aerostructures continue to make technical advancements, it's also true we established a thorough system in which our practices were documented and ready to hand over to new members of the team. Making sure things are where they need to be in the state they need to be in for testing, week in and week out, is no easy feat, but one we conquered. Thank you. Now, I think you already got a sneak peek of it, but apart from building two airframes, here's what we did in 23.
Overweight and have an inefficient and unoptimized design. Another drawback is the excessive use of aluminum, which requires a long manufacturing time. Due to its structural significance and the demand to cutting down the aircraft weight, last year we revisited the wing internal optimization and came up with a new design approach. To accommodate a more complex design, a custom spar analysis program was created, which can evaluate the maximum stress of the structure and provide the required spar parameters. Based on the software output, we decided to use balsa wood strip interwoven with carbon fiber for the main spar body. Aluminum was removed from the connector and replaced by carbon plating to increase the strength to weight ratio and the ease of use. The whole structure was together laid up to allow for a more accurate installation into the wing, resulting in a higher degree of alignment. The new wing internal structure have halved in weight compared to the previous iteration, to reach a total of 750 grams while still able to meet the 3G strain requirement.
The fuselage, the core of our drone, received a major upgrade. We redesigned most of its internals for better structural integrity and ease of use, ensuring it can withstand the rigours of flight and challenging rescue operations. To do this, the crux underwent a significant redesign, greatly increasing its strength and rigidity. The new design focused on a more modular approach for mounting the aircraft internals. The two rails were designed such that internal components could be easily mounted, shifted around or replaced with minimal effort, and more importantly, without the need to redesign the fuselage. Taking full advantage of our new modular capabilities, a battery module was designed and installed. Previously, changing batteries was a cumbersome process, first removing the bottom half of the fuselage and undoing the straps which held the battery to a flimsy plate. The new design now allows for top hatch access, where batteries are held in only by a friction fit, and thus can be removed without any tooling and by a single person in a matter of seconds. This is not an improvement for convenience, but an essential safety feature, especially in the case of LiPo fires. This symbolises our commitment to safety, efficiency and innovation. It is a testament to our team's ability to identify challenges and turn them into opportunities for advancement.
The
big step that we took in 2023 was our increased use of stronger aluminium parts in our aircraft, made possible through our newly acquired skills in CNC milling. Thanks to our sponsor, Carm Aluminium, we were able to use 6061 T6 aluminium for our parts, a first for Monash UAS. 6061 T6 is a grade of aluminium renowned for its impressive strength to weight ratio, a big reason why many aerospace companies around the world use it extensively in their aircraft, no matter their size. Using this aluminium, along with our CNC mill, we were able to manufacture our tail components in-house for the very first time, and also massively simplify our wing connector assembly to just 3 parts per side. That is half the amount of components required for Albatros V2's wing connectors, while still improving the entire assembly's strength and weight characteristics. And best of all, we managed to design and machine our very own singular piece VTOL motor mounts, with inbuilt features allowing us to ensure that our motors are exactly 2 degrees offset from the aircraft's horizontal plane, giving us better control of the aircraft's directional heading.
One shortcoming of the Albatros V2 was that it was susceptible to wing failure due to the epoxy cracking between the skin and spars. After just a few flights, the epoxy needed repair and reapplication, which was not only challenging to do, but also put our aircraft out of service for weeks. We needed an adhesive that was not just stronger, but also more resilient and dependable. Our search led us to a comprehensive testing regime using the hydraulic press in the civil engineering labs. We explored numerous compounds, examining their bonding strength, flexibility, and durability under various conditions. This involved laying up carbon fibre plates, clamping the samples in a hydraulic press with our in-house built jig, and extracting data measuring the force applied against displacement. After rigorous testing, we found that Technicolor R60 emerged as the clear winner, showcasing exceptional bonding strength and redefining our expectations. During our test, we discovered that when we bonded 2 carbon fibre parts with Technicolor R60, it was the carbon fibre that failed under stress, not the glue. This was a revelation. The R60 didn't just adhere, it formed a bond stronger than the materials it was joining. This discovery has revolutionised our approach to manufacturing and maintenance. No longer are we constrained by the weaknesses of traditional adhesives. With Technicolor R60, we have a solution that ensures our aircraft are more robust, more reliable, and can be maintained with greater efficiency.
Please give a warm welcome to our 2024 Avionics leads, Maddie Armstrong and Kian Rodriguez.
Hi, I'm Kian, and joining me tonight is Maddie, and together we are your 2024 Avionics leads. When MUAS was founded back in 2011, avionics was just seen as a barrier to getting the aircraft off the ground, and the team was mainly comprised of mechanical and aerospace engineering students. 13 years on, the avionics section is a vital cornerstone to MUAS's mission of the humanitarian potential of UAVs. The section focuses on both the hardware and software that controls our aircraft. This ranges from custom circuit boards and wiring harnesses to the software systems that control them. Here's a quick rundown of what we got up to in the past year.
Towards the end of 2023, unfortunately, we had to say goodbye to some of our incredible senior members. However, we had a massive renewal last year with 18 new members recruited across 3 recruitment rounds. This was made possible due to a documentation push within the section to make handover as smooth as possible, something that we have neglected in the past. In the months following their recruitment were filled with training sessions and workshops meant to give all of our recruits the relevant skills to slot into any of our avionics projects. So far, we're really impressed with the calibre of our 2023 recruits, and we're really excited to see everything that they accomplish during their time spent on the team.
We also made it a key focus to empower women in STEM to take up leadership positions within the team. We saw 3 women take up project leadership, not including our very own avionics co-lead, Maddie Armstrong. We hope to continue this trend going into the new year, and we are actively committed to increasing diversity within avionics.
2023 saw the conclusion of our RTK GPS project. We were able to successfully add centimetre-level precision to the Albatross through the use of a tripod-mounted ground antenna coupled with a patch antenna on board the aircraft. This massively increased the accuracy of our coordinate estimates for points of interest highlighted by our computer vision software.
In 2023, we launched our payload deployment project, nicknamed Project Lifeline. This is one of our most ambitious projects to date, with just under a third of the section working tirelessly to integrate the system together alongside their aerostructures counterparts.
We also kicked off the development of our in-house gimbal system. We sought to develop our own solution to camera stabilisation due to budgetary constraints. In doing so, the team have produced an impressive system capable of rivaling off-the-shelf solutions, and you'll hear more about our technical projects from their respective leads shortly.
Whilst in 2022, we spent the year working on all the individual components that comprise the Albatross, 2023 marked the year where we got to see them all working together, integrated on a complete aircraft for the very first time. It was so fulfilling to see the culmination of all the hard work our sections put in over the past 2.5 years, and we are so proud of the progress we've made so far.
Kian and I are so lucky to be leading such an incredible group of engineers, and they do really make our job easy. But this absolutely isn't the end for Avionics. We have a long way to go and a lot of work to do in 2024, and we are really keen to get started. So let's hear from some of our technical project leads and hear what they got up to over the past year.
The stack acts like a bridge linking the flight controller, essentially the brain of our plane, to all the peripheral devices responsible for controlling Horizon's movements. The stack is comprised of two sections, power and communications. It is the integration of both these systems that enables our plane to fly.
Since the design of Phoenix last year, the Avionics stack team has worked hard to make the electrical stack as optimized as possible. This has involved changing the placement of our electronic speed controllers and CAN nodes to simplify our wiring. With the upcoming design cycle this year, our team will continue to focus on making the electrical stack as easy to access and debug as possible.
Monash UAS's Power Distribution Board, or PDB for short, is a custom-built circuit board stack that serves as the centre of the Albatross's power management system. The PDB is made up of 3 boards which are connected to form the single integrated stack.
As the name suggests, the PDB takes power from the batteries and distributes it to the various peripherals and motors throughout the entire aircraft by adjusting the voltage. Some of the additional features of the power distribution board include current monitoring, temperature sensing, and emergency stop technology.
This crucial component of our aircraft is developed in the Altium Designer software, which is an excellent tool for both designing the physical layout of the board and the schematics. As we head into 2024, our team will be designing the latest iteration of the PDB for our next generation of aircraft.
DroneLink is UAS's custom-built, in-house mission management software tailored to our pilots' needs. It features an intuitive general user interface that displays flight-critical information such as live aircraft speed, location of the drone, onboard camera feeds, battery data, and much more, allowing our pilots to easily monitor and analyze the mission.
A mission begins by planning a search area and inputting the boundary coordinates. The path generation algorithm computes the optimal path, taking into consideration the plane's turning radius and camera's field of view. It aims to minimise turning to give a more stable feed for the onboard camera. A settings menu is also designed to allow pilots to adjust every parameter related to path generation.
Our application also automates the actions of the plane upon detection of a patient on the ground. If patient detection is confirmed, DroneLink will command the plane to travel to the patient and orbit them, and will show our inbuilt interface for the lead pilot to choose a safe deployment location for life-saving medical supplies. The plane will automatically travel to this location, deploy the supplies, and then return to orbit the patient for monitoring purposes.
Welcome to Vision. In this project, our main objective is to detect a person and to determine their GPS coordinates. This process can be broken into 4 simple steps. Collect footage from the onboard camera, detect a person, determine their location, and initiate rescue efforts. All of this is done while sending camera feed to mission management, allowing the ground station operators to monitor the situation in real time and assess for hazards. During flight, footage is collected using a high-quality camera, which is then processed by downsampling images, allowing for dramatically faster processing. These images are then fed into an AI model that has been trained specifically to detect people. This is done by creating a large dataset of images that simulate a variety of rescue missions. These images are then categorized into classes with bounding boxes around people. Image exposure and orientation augmentations enhance people detection across diverse scenarios. These images are then fed into a neural network which trains a patient-detecting AI. These highly demanding processes are made possible by the state-of-the-art onboard computer designed specifically for AI applications. Once a person has been detected, their GPS location is then determined with sub-meter accuracy. As the plane's precise location, speed, altitude, and bearing are known, every point on the image collected can be located. After this, the coordinates are then sent to ground station and an orbit command is triggered, which sends the drone in a circular motion around the person's coordinates. Vision systems are then used to monitor and assess the situation, allowing for better coordination of rescue efforts. And just like that, Vision has helped a person in need to see another day.
To facilitate the visual capabilities of the Albatross, Monash UAS has developed a customized gimbal, essential to house the AI-suited camera and to provide stable footage during aircraft maneuvers. The gimbal is capable of leveraging multiple sensors and systems, such as Vision's AI system. This allows for AI-powered patient tracking and for continuous GPS tracking during aircraft maneuvers. In addition, the gimbal listens to any commands from any connected device, such as mission management. This allows for smart and automated decision-making and for manual input from the crew when desired.
The electronics of the gimbal utilise an open source hardware design that we have tailored for our specific use case. Manufacturing the controller board, motor drivers and IMU in-house has allowed us to seamlessly integrate to both the electronic and mechanical aspects of the gimbal, simplifying wiring and installation, as well as making it significantly cheaper. The gimbal features brushless motors and magnetic position encoding to enable advanced, high-efficiency control schemes, reducing overall power consumption and heat generation. The gimbal also prioritises an aerodynamic design by adopting a spherical shape and leveraging advanced design techniques to reduce on weight while maintaining its structural stability. Finally, an ergonomic handheld controller was designed for usability. The controller displays the live camera feed and enables remote control for an increased visual flexibility and search efficiency during flight.
To allow for real-time updates of the Vision system, Pipeline was formed. Pipeline is one of the systems that UAS uses to communicate data back to the ground station. While the standard communication link used by UAS is fully capable of sending messages like telemetry, a real-time video link is beyond what it is capable of. For this reason, Pipeline is a dedicated system that uses the 4G network to send the large amounts of data needed for a video. The server is integrated as part of the system to forward the data to mission management. Thus, the combined system allows us to see when Vision detects a patient, rather than waiting until the drone returns to base to gather data logs.
In the pursuit of realizing our vision to aid humanitarian rescue, we proudly introduce Project Lifeline. Its purpose is to develop a payload deployment system that can carry and deliver essential supplies to patients in need during search and rescue operations. Our project is made up of multiple components that ensure the secure delivery of our payload. It starts with the bay doors, which are integrated into the bottom fuselage and are actuated by a pair of servos. Once the doors are open, a tethered freefall will enable our payload to descend rapidly to the target location. As the payload approaches the ground, our braking system will ensure its smooth deceleration to a full stop.
Next, our innovative release mechanism will deploy the payload. This consists of our impulse driver that will shorten the release cable, effectively pulling it and releasing our payload carrier latch. Finally, the payload carrier will be retracted back into our drone and the bay doors will close. The Albatross is now ready to return to the ground station. In the event of an emergency, we must efficiently eject the payload. Our Nichrome failsafe system is capable of burning through the cables in a fraction of a second, ensuring a swift response to critical situations where our release system may falter.
Where it seemed the chances of success diminished further and further with each failed attempt. But it was in these final moments that the team truly shined. Our best work was done, and never so quickly would things be turned around. From the first stable flight of Phoenix to our first ever transition, there has truly been no shortage of moments that will stay with me forever. And when I look out into the audience and I see the team, I know that you know that these are the moments that make it all worthwhile. Because here at UAS, we may crash a lot, but each time we do, we learn. We rebuild, we fly, we crash, we rebuild, and we fly again until we succeed. And never before have I come across a more resilient group of individuals. No matter how many hurdles, challenges, last-minute curveballs, your determination, in spite of relentless hardship, never ceases to amaze me. And it has been an absolute privilege to be a part of such an amazing group of people. There is much to be said about the 2023 demonstration. The truth is, it didn't turn out quite as we'd hoped. Our filming days were plagued with equipment failures, technical difficulties, and the aircraft faced some of the harshest weather I've ever flown it in. Our cruise motor, which took us into forward flight, had burnt out at our final testing day just 2 weeks prior to filming. Without any replacements, the team threw together 3 separate contingencies, 2 of which weren't able to get us up to past stall speed, and the third never got the opportunity to be tested. The final nail in the coffin, after over 60 successful flights on Horizon and several flights that day, a fatigue failure in a solder joint of one of our 6 motor power wires brought the aircraft down shortly after takeoff. The failure not quite significant enough to be detected during pre-flight checks, but just enough to cause the motor to fail to deliver full throttle under load. Fortunately, the only casualty of this incident, as is becoming quite commonplace on this team, was our expertly designed fail-first landing gear. And the learnings from this experience have already been acted upon by the Avionics stack team, who have completely dissected the wiring harness, repairing and repositioning our solder joints to less stress-prone areas. The 2023 demonstration overall, although not filmed and greeting you on the screens tonight, was by no means a failure. Our mission projects have all made incredible progress in demonstrating practical outcomes, ones that could be used to save lives. Our gimbal can be controlled remotely and autonomously and stabilises the camera footage considerably, allowing it to be used to monitor a patient's condition. Our vision system has been able to detect a patient at a cruise altitude of 80 metres, where even a first responder may struggle to be able to see them. It also detects cows, but we're working on it. Our mission management software has been used to perform autonomous missions from start to finish and acts as a valuable addition to Mission Planner for pilots to perform all the actions they may require, especially in high wind scenarios. And our Lifeline project has demonstrated core delivery functionality from low altitudes, as well as an ingenious failsafe that allows us to proceed with the safe testing of higher altitude cable deployment method for rescues in difficult to access areas. The projects, they're there. And with an aircraft that has already demonstrated its capacity to fly a search pattern, all that is needed is to bring them all together. Can they be made better? Absolutely. And our project members are already teaming with ideas for improvements in safety, reliability, and efficiency, all to make Horizon an even more valuable search and rescue tool. Despite the demonstration never coming to fruition in the medium we hoped, we have still achieved an incredible amount in the past year. We've built not 1, but 2 aircraft, trained an incredible group of passionate recruits, reignited our outreach and social media presence, and nurtured an incredible team culture of passion and community. When I look back on the last year, it's easy to forget that many of the people that you've seen here tonight were actually new to the team in 2023.
This year was all about creating a strong foundation for the team to thrive going forwards, and to see how our recruits have come, how far they've come in such a short time, to have grown, flourished, and developed into the leaders of the future fills me with optimism and pride. I am so very excited to see where you all take the team tomorrow. So without further ado, it is my absolute pleasure to formally introduce you all to the 2024 management team, led by Mr. Dilshan Fernando and Mr. William Lee as team lead and chief engineer, with Nikhil Pocharel and Thomas Buno as aerostructures leads, Maddie Armstrong and Kian Rodriguez as avionics leads, George Dimitropoulos and Jed Briggs as flight ops leads, Iris Lai as operations lead, Eric Yu and William Lin as finance leads, and Ava Bryant, former chief engineer, returning to lead the all-new section, propulsion. Could we please get a round of applause for the 2024 management team? Now, please join me in welcoming to the stage the inseparable duo, former avionics leads Will Shan, to share their vision for the future with you.
Thank you, Jordan, for the introduction. Hello, everyone. I'm Dilshan Fernando, as Jordan mentioned, and this is Will, just in case you guys can't tell us apart. I know we look kind of similar. But yes, I think, first of all, let's start off with a moment of appreciation for the 2023 management team. I know it's kind of like patting ourselves on the back because we were the avionics leads, but I think the whole management team went through countless hours of hard work and countless challenges that were surmounted. And we've left the team in a very enviable position. One that I hope that our new management team can push even further this year. Going into 2024, I think the team is in a position where we're poised to thrive in. With such an increase in community engagement and team presence, I think that it's safe to say that we've entered a new era. One that I think will rise to even greater heights than our predecessors. With such a strong foundation, I think the team has come to the conclusion that it's time to face a new challenge. One that we hope will take our team to show off its prowess on an international level. It is my great pleasure to reveal to each and every one of you that Monash UAS is participating in the new flying competition hosted in Germany for 2025.
The competition is based in Germany, focused on building an electrical aircraft powered by the most efficient propulsion system possible. The aircraft has to carry a minimum payload of 1 kilogram while also maximizing the amount of payload volume available. The competition itself consists of 2 flights, where the aircraft will be pitted against a reference aircraft to determine the scores. The first flight requires the execution of the sequence of maneuvers, such as a 360-degree left and right turn, a 3G maneuver, like a barrel roll, a minimum and maximum speed flight, a no-thrust gliding flight, and concludes in a minimum distance landing. The second flight is an endurance flight, to fly as far as possible given the same payload configuration as the first flight.
With all these requirements, you might be wondering, what's so humanitarian about this? You know, our mission and our vision is to develop drone technology in a way that's beneficial for humanity. And this was probably the biggest point of contention as we decided what direction we wanted to take this year. However, in these deliberations, we discovered that having access to a highly efficient, high-performance drone opened up so many avenues that weren't open to us with our current Albatross design. Things like fire spotting or animal monitoring, geosurveying, or even communication relay are all paths that open with the development of a fundamentally different airframe. In 2024, we're ready for the challenge. It's a brand new opportunity for the team, and I think that we're going to make the most of it.
NFC isn't our only aspiration this year, though. As we've mentioned before, we've spent a lot of hard work in 2023. We aren't going to abandon all the potential of our Horizon aircraft. So while we are developing for NFC, we'll be aiming to improve and demonstrate the various systems in their ultimate forms. Our mission systems, such as Lifeline, Vision, and Gimbal, still have so much good to give. This means that over the course of this year, we'll be refining the ideas and show off to the world just how amazing they can be when given the time to blossom.
All these major developments we documented on our social media. We're planning on making several key posts to make sure you guys know when we hit every single milestone for the year. However, these two major projects aren't the only ones that you'll get to view for the year. Our team will be continuing development and advancing fields simultaneously, and some of these developments will be pushing us into fields that we have yet to explore at all.
The first one is that we've got a new section called propulsion. They're going to be doing a lot of hard work in 2024 in the research and development field. The aim is to develop customized propellers, motors, and ESCs. This will allow us to fine-tune these things to our performance needs. This will become a vital step to propel Monash UAS into the next step.
Alongside this development, our team will also be delving into the advancing field of hydrogen-powered aircraft. With a promising team of final year students of Jordan Semyonov, Daniel Pooley, Warren Rogan, and Samuel Waite, we will be embarking on an investigation to research, design, and prototype our very own hydrogen fuel cells. Within this investigation, our team will be determining the feasibility of our team adopting this technology, but we are hoping that in the next 3 years, we'll be able to develop our very own hydrogen-powered unmanned aircraft that is purpose-built for the sole reason of benefiting humanity.
All the work that we have done so far would not have been possible without the thanks to our sponsors and industry partners such as XM2 and Leap Australia, our partners for tonight's event. Monash UAS has taken great leaps thanks to the expertise that they have provided. The experience that we've gained as an opportunity from their ongoing support has become invaluable to the team. It has become the key to success in our journey to demonstrate the potential of UAVs in the humanitarian scene. Going forward into 2024, we hope to foster an even deeper relationship while bringing in a host of new collaborators to help us reach our next height.
We've already ignited communications with several sponsors by hosting some workshop visits this year. From the likes of Stalmetal, who produce professional-grade wiring looms, to even companies like Ironbark Composites, who provide the team with our carbon fibre, with the industrial know-how of how to do our composite layout, to even companies like CubePilot, who produce world-class flight controllers and generously provide us with their products to make our mission that much more attainable. We are still looking to reach out to more companies. Every new bridge we take, we believe can push our team up to the next level. So, if you know a company or you yourself are part of a company that you feel like would be interested in partnering with the team, feel free to talk to any one of our members. We're all open to that conversation and we are very excited to foster every single relationship that we can. These relationships are just one avenue for our own success, but we need every single bit of help that we can get. Every tidbit of knowledge, every dollar, every industry secret can be the one that is crucial to our success. So please, feel free to talk to our members, donate to our vision, or even just spread our name to those who may be interested. Really, ultimately, it's the support of our community that gets us, ultimately it's the support of our community that has brought us where we are today. Whether it's the industry partners or even our friends and family who are here supporting us. We really value every single little bit that you give us, and it is our desire to show you guys how amazing we are as a team, all due to your support. I'd be remiss not to acknowledge the help that we already receive. We have several major benefactors, and it's hard to mention our name without mentioning Monash University. Obviously, it is the great work of the Monash Student Team Initiative, with special mention to Scott Worthy, Alexander Unmack, Isaac Sims, and Becca Lee. It's hard to say that our teams would exist without you. All the help that you give us, well, not only us, but every single student team run by Monash, is extremely appreciated. And I hope you guys love seeing the work that we do as much as we love the support that we get from you guys. And finally, it is my ultimate honor to be able to thank each and every single one of the 2023 MUAS team. I see you guys all up in the back there, and I hope you understand just how amazing the work you do is. When I was thinking about applying for team lead, it was the fact that I had a team that was so trustworthy and fun to be around, that really pushed me to the edge to actually apply. And I've not had a single regret since taking up this position. I could not be more excited for the work that we're going to complete in 2024, and I'm so excited to see everything that you guys will achieve.
This brings us to our final announcement for tonight's event. Monash UAS is happy to announce that we are opening our 2024 recruitments tonight. We often find that when people think of a student team, that they think there must be an engineer to apply. However, that is far from the truth. Our team is very multiple disciplinary. We are always on the lookout for people from various backgrounds, such as commerce, law, science, or art, to help us in our endeavour to demonstrate, educate, and to inspire the next generation. We highly encourage any student from any background to apply.
Our applications close on the 10th of March, so make sure you apply as soon as possible. I think this presentation has been a pretty good argument as to why you should join our team, but just in case you're not convinced, I would like to draw your eyes to the big screen to show you a small trailer about us, filmed and edited by our event partner tonight, XM2. Again, thank you all for making the time to come down to our presentation. We look forward to showing all of you just how high we can fly this year. Thank you.
Thank you all so much. That concludes the presentation section of the night. Could I please invite you to join us upstairs for refreshments?